All right, let's go ahead and practice this just a little bit more here with the last page. And so once again, we have our graphs this time of the inequality. You'll notice that this first graph up here has a y is greater than x minus 2. So you'll notice that the y-intercept value is negative 2. Its slope is positive 1, so you'll see this graph. It is going to be a dashed line because it's not equal to. Any points on the line would not be solutions, but the points that are above the line are solutions, and that's why it is shaded above the line. So we see that in the graph that's already done. So we'll notice now down below, it says 2, 3, remember that's an x value of 2 and a y value of 3, is in the shaded area. Let's just graph that. So 2, 3 is this point right here. That's 2, 3. Use the inequality statement to show why it is a solution. Okay, so if it's 2, 3, that means we're going to take the 2 and put it in for x, and the 3, and we're going to put it in for y. And once again, we're going to show why this is true. So we're going to put 3 in for y, and we're going to put 2 in for x. All right, so instead of y is greater than x minus 2, we put 2 in for x, and we put 3 in for y. So if we do this, this is pretty straightforward here. 2 minus 2 would be 0. So is this true? Is 3 greater than 0? Yes. Okay, so this is true. All right, so that means that 2, 3 is a solution because it makes the inequality true. Okay, so let's go ahead and look at this one, 0, negative 2. So again, 0, negative 2, actually that's that y-intercept point that we graphed. That's on the dashed line. Use this inequality statement to show why this is not a solution. So if we put negative 2 in for y and 0 in for x, so remember our inequality was y is greater than x minus 2. So if we put negative 2 in for y and 0 in for x, does this make a true statement? Well, let's just simplify this a little bit. Is negative 2 greater than, let's see, 0 minus 2 would be negative 2. Is negative 2 greater than negative 2? No, it's equal. Negative 2 is equal to negative 2, so no. So this is not true. So not a solution. All right. So 0, negative 2 is not a solution because it doesn't make the inequality true. All right, let's do that over on the next one. So here's our new equation. Notice it has an equal sign now, so it's a solid line. It's less than or equal to. All right, it has a y-intercept of 2 and a slope of 2. It's being graphed. Notice that it's shaded below the line because it's less than or equal to. So let's take this point right here, this x and y value, negative 4, 2. So negative 4, positive 2. Notice that is not in the shaded area. Use the inequality statement to show why it is not a solution. So I'm just going to write the inequality statement this time. So this is our inequality statement. And now we're going to put 2 in for the y and negative 4 in for the x. And the question is this true? All right, so 2 is 2 less than or equal to, let's see, 2 times negative 4 would be negative 8. All right, is 2 less than or equal to negative 8 plus 2? Negative 8 plus 2 would be negative 6. Is 2 less than or equal to negative 6? No, this is not true. Right? 2 is actually greater than negative 6. Right? 2 is a positive number, and negative 6 is a negative number, so 2 is greater than negative 6. If it were a temperature, 2 would be warmer than -6 degrees. So that is why this is not a solution. It doesn't make the inequality true. It's not in the shaded area. It doesn't make the inequality true. What about this point right here? This point, -3, -4. So -3, -4 is right here. Right? It is on the line. Use the inequality statement to show why this is a solution. All right, so once again, the inequality was y is less than or equal to 2x plus 2. So let's go ahead and put -4 in for the y and -3 in for the x and ask ourselves, is this a true statement? Let's simplify. 2 times -3 is -6. So is -4 less than or equal to -6 plus 2? All right, -6 plus 2 is -4. Is -4 less than or equal to -4? Yes, it is equal to -4, so that is true. So -3, -4 is a solution. So on this page, we took some examples of the graph that was already done for us and showed why points in the shaded area are solutions, why points on the dotted line are not solutions, why points on the solid line are solutions, and why points in the completely unshaded area are not solutions. So shaded area, always a solution. If it's on the line, we have to ask ourselves, is the inequality equal to, or is it just a greater than or less than symbol to determine whether that is a solution or not?